Okay, I would like to solve this, perhaps the most famous complement of an event problem. That is this. If there are 50 people in the room, what's the chance that two people would share the same birthday? This is not about the same year, but not the same year, but same birthday only. So, how do we do this? I mean, this gets complicated. There could be 25 pairs that share the same birthdays, two each. There could be three sharing birthdays, several clusters of them, or they could be all 50 sharing the same birthday. How can we account for all these possibilities? Feeling dizzy, right? There are so many possibilities. There could be 5 people sharing, then 3 here and 7 there, and all these are just impossible to compute. There are so many ways. When you feel that way, it's time to do complement of an event. So I'm not going to find the probability that 2 shares the same birthday. I will find 1 minus no shared birthdays. Okay, how do we do that? Let's have a room here. It's an empty room. Whenever you do probability of so many people and so many dice, so many coins, don't think of all of them at the same time. Toss one at a time, then you will see a lot better. So we will let one person enter the room at a time. Then it will be a lot easier. Let's have the first person enter the room. We are doing this, no shared birthday. What's the chance that he shares? We're looking for no shared birthday. So what's the chance that he does not share the birthday with nobody in the room? Of course, there's nobody to share birthday with, so it's 100% that he does not share the birthday with nobody to share with. Now, it gets interesting when the second guy walks in. What's the chance that he does not share the birthday with the first guy? Right? Now, when the third guy comes in, what's the probability that he does not share the birthday with these 2 guys? Out of whole year, you got to take 2 days out of for one for each. We know they are different, right? That's how we pick this guy. So that's what's left. When fourth guy comes here, we don't know which day they are, but on the calendar, the 3 days are taken out by these. So he has to pick one of those remaining days to be his birthday. And when the fifth guy comes in, and so on. So what would be the 50th guy's story here? Of course, he will have to pick a day out of 365 days. We're ignoring the leap year. Okay, how many ways? Okay, now see. 1, see. Second guy, this was the first guy. This is how you think of these things. And third guy, if I add this, let's do it here. You get 366. If I add this, I get 366. If you add this, you then get, because it's the fourth guy, right? If you add this with that, you get 366. We are dealing with 350th guy, so I have to get 366. So that's what I get. Okay? Do not just subtract 50. Then you would get wrong here. You got to think of that, how the numbers are offset. So that's the last number, and if I multiply all these, then I would get the probability that 50 people do not share the birthday. Nobody shares the birthday. I'm curious, so what would that number be? To compute this, I will tweak this one to a different number. Instead of saying 1, I will say 365 over 365. Not only is it 1, but it makes sense, right? When he walked in, he could choose 365 days out of 365 days to avoid sharing birthday with anyone because there was nobody. So this is what we got. Can we write this in a more expressive way? That is, in a more mathematically succinct. That's 365 to the, not nth power. That's my next step. 50th power. Okay, what about here? It's a factorial business, right? This one. So it's a 365 factorial divided by, I got to end with 316, so I got to have 315 factorial. If I do that, you realize what I have is 365 to the 50th power, and I have 365 factorial, What is 315? It's 365 minus 50. That's what it was. Okay. Now, so this is the probability that no two people share the same birthday in a room with 50 people inside. Okay, now, so what's the chance that, let's go to the problem. What is the chance that at least two people, share the birthday? Well, complement. We just found this, So you got to do 1 minus what we found will be the answer we are looking for. So let's do 1 minus what we found. 365 factorial over 365 minus 50 over 365 to the 50th. So that's my probability that I'm looking for. Okay, let's get a little bit more fancy here. Can we do n? Probability that given, if there are n people in the room, what's the chance that at least two people would share the birthday? That would be 1 minus 365 days factorial, 365 minus n, right? Instead of 50, we are using n divided by 365 to the nth power. So that's the general form, of which when we say n is 50, then we have this case here. So that's the formula. Aren't you curious about what this number would be? Indeed, if you see run some seminar and 50 people came, aren't you curious? What are the chances that at least two people in the room shares the same birthday? We will find out.